sketching curve. So we're talking about the PDF, CDF. This time we're going to talk about the exponential curve. So the exponential distribution. So the PDF function for that is lambda e to the minus lambda x, and x has to be greater than or equal to 0, and lambda is mean number of arrivals. Okay, so just to as a refresher, this is e to the x. We have a minus sign here, so we're going to flip it there. So it flips it on the y-axis, and we have lambda here. That's going to be at the start, and then because we have, it has to be x is positive here, we don't want that piece, so we are just going to keep this piece of it. Okay, so what does our curve look like? It turns on at 0 and it's off for negative values, and it's going to start at lambda because when you plug in 0 into this piece, this is e to the 0, which is 1, so it's going to start at lambda, and then it's going to trail off. And because this is exponential, it's got a tail here. So these are small values, but they do have a chance of occurring. So these, remember, the x-axis is your observation. So this is the length between arrivals. So it's the time between arrivals. And this is your chance that that particular observation happens. Sorry, f of x. Okay, what about the CDF graph? So this is the PDF graph. CDF graph. Okay, so that you have no chance of seeing an arrival before 0, right? So you can't have negative values for this. And then here it's going to turn on, and it's going to shut off at 1, but because you have a tail region here, you have an asymptotically close for larger values, but it's going to come in and then do something like this. Actually, it's got a kink right there at 0, but it looks sort of shaped like this. This is, again, these are the x values. So these are your outcomes. So a particular outcome, and then this is measuring the chance of seeing this outcome, seeing any observation less than or equal to a particular outcome value. Okay, and so it represents the area under the curve of everything up to that particular outcome on the PDF graph. Because remember, the CDF is going to be minus infinity up to x of your PDF. This is generally true, and so this is the bound there. So this is the upper bound, and so this CDF is measuring the area under the entire curve for everything up to some particular x there.